Hello, Assalamualaikum. My name is Noratika Shahira binti Uyup. Now, we will present about our report for experiment 5, which is bending moment. So, we are from group 3. The representative for this report are Noratika Shahira binti Uyup, which is me, and Muhammad Adam Lukman bin Razali. So for the next slide, I will do the introduction for this experiment. The introduction for this experiment is about the shear force is defined as the algebraic sum of all vertical forces operating on either side of a load beam at any location, which is positive. Moment always counterclockwise caused by weight operating to the left of the reaction are believed to be negative. The beam is bent by the bending moment. So, the next slide is show about the objective for this experiment is to measure the bending moment of material when subjected to different loads at different distance. So, the theory for this experiment is about the bending moment can define where the torque that keeps a beam together, or also can be defined as a force that causes something to bend. The formula is moment equals to force times width distance. We cutting the beam, then calculate the algebraic sum of the moment required of all forces that are acting in one side of the section, either left half side or right half side, to hold the beam stationary. As you can see, for the first diagram A, a cantilever beam is acted upon by a vertical force, which is P, to the downward. And the B is the shear force downward at the blue region, you can see. And the C is show the bending moment counterclockwise for this condition in the red box.
Assalamualaikum. My name is Muhammad Adam Lukman bin Razali. Today I will present the methodology, result and calculation for the experiment 5, which is bending moment. I am from group 3. For the methodology part 1, P1 was placed in the middle of the smaller part A, which is 100 mm from A of the beam. P3 was placed on the large part B, which is 600 mm from part A, and P2 was placed adjoining just over the bearing pin, which is 300 mm from part A. Second, the spring balance was adjusted to align the two parts of the beam, and the initial reading of the spring balance was recorded. The P1 hug with 5 Newton weight. The beam was realigned and the new spring balance measurement was recorded. The effect of the 5 Newton weight of the beam is the difference between two readings. This weight distance from the right hand support was measured. The second next, the method was repeated with the hanger on part B, P3 and the hanger over the bearing P2. Finally, the whole procedure was repeated using 10 Newton, 15 Newton, 20 Newton and 25 load. Next, for the part 2, the methodology, 3 load. First, the 3 load hanger were positioned as part 1. The beam was realigned. The initial reading of the spring balance was noted. 10 Newton was applied at P1 and 20 applied at P3. The beam was realigned and the new balance reading was noted. The procedure was repeated for the next load in the table 2. The part B, part 2B, the P2 is fit at the same location as the before. P1 is 100 mm and P3 is adjusted to be 300 mm from P2. 10 Newton load applied at P1 and 20 Newton load applied at P3. The spring balance was realigned and reading was recorded. The next, P1 is 150 mm and P3 is adjusted to be 300 mm from P2. 10 Newton load is applied at P1 and 20 load is 20 Newton load is applied at P3. The stream balance was realigned and the reading was taken. This are for the methodology. For the result, this is the result we get from the experiment. For the part 1, we have 5 different load, which is 5, 10, 50, 20 and 25. And next is the result for part 2A and B, which is different distance. And the calculation, this is the formula we use to calculate the net force, which value of load 10 Newton minus value of 0 Newton, which is 0 load for 0 Newton. Next, bending moment. Bending moment for the experiment, which is net force times 150 millimeter, and the theoretical value of the bending moment we can calculate using the bending moment equal to 0 formula. The next, this is the sample calculation for part 1 for the load. For the theoretical value bending moment, we use summation of bending moment at B equal to 0, which is we can calculate the RA and we can calculate the bending moment at MC. This is the graph you obtain when we calculate the value of the bending moment and over the distance. This graph obtain the experiment value and theoretical value. The next, the sample calculation for part 2AB, we using the theoretical value to calculate the theoretical value of the bending moment, which is we using the summation of the bending moment at B equal to 0, and we can calculate the RA and also we can calculate the summation of bending moment at MC, which is 300. That's all from the calculation.
Okay, now I will explain about the discussion for this experiment. As you can see, the discussion for this experiment is where, based on the theoretical value obtained from part A of experiment, it shows that the bending moment is directly proportional with the load added. The relationship between the stress, bending moment and the load is that when the load increases, the stress increases and make the value of bending moment increases. Therefore, the ratio of the increase in bending moment value is relative to the load. As you can see at the table 1, is the data for bending moment at C, which is moment C for the load configuration in part 1. So for the next discussion, we need to do the comparison between the bending moment value obtained from the experimental and the theoretical calculation. So after that, we provide the justification for any differences. First, look at this slide. You can see the percentage error we calculate with the modulus experimental value minus with theoretical value and divided with theoretical value times with 100%. We calculate the percentage error, which is this is the example until the load 50. So we get the percentage error for the bending moment experimental and the theoretical value, the differences. And next, so the next slide is showed for the part B, which is the percentage error that we calculate for the part B, and we get the larger percentage error, which is 40%. So the next discussion, I need to justify what the differences for our experiments is. First, the errors. The error that we do is the parallax error and the hanger position. Next, the equipment are not sensitive. The last one is about the movement of air surrounding. But the precaution that we need to do is the observer's eyes must be perpendicular to the scale of the measuring instrument. And the next is we need to check the position of the load hanger And the third is we use the more sensitive equipment. And the last one, we switch off fans while conducting the experiment. Okay, the last slide, which is the conclusion for this experiment. In conclusion, we are be able to determine the relationship between experimental and theoretical bending moments when the load being applied to the load hanger, where the bending moment is directly proportional to the load applied. Furthermore, we also able to study the bending moment varies with increasing load, and bending moment varies at the cut position of the beam for the various loading conditions. Where when the load is increased, the bending moment also increase. In sums, we need a precision and care while taking the readings such as the spring balance scales, and make sure that the bubble in the balance located in the middle before we taking the scale reading. I think that's all from us. Thank you.